Good morning. Once again, you're welcome to this Math App seminar on algebra. We are going to begin right now. I hope you can all see my screen, and I hope you can all hear me. I just need confirmation from one person that I can be heard, and you can see my screen. Okay, nice. So the questions that we're going to be discussing have been sent in the chat. They'll be sent again for those who are just joining. But yes, the questions that we're discussing today have been sent in the chat and also in the Math App WhatsApp groups. So you should be able to access them as the seminar goes on. And this will be the first question that we do. It's a seminar on algebra, so there'll be questions on indices, logs, a bit of surds, a bit of partial fractions, and a few other topics as we go on. Algebra is quite wide. So this is the first question, and we're going to do it together. So I've been asked to solve for x in this equation. The root of 3 to the power x plus 1 plus 2 minus the root of 3 to the power x minus 1 is equal to 2. Now, when you have square roots like that, we cannot make any progress unless we get rid of those square roots. So the first step really is to square intuitively. But you know, when you square, there's going to be another square root that pops out because from this expansion, a minus b squared is equal to a squared minus 2ab plus b squared, which means that if one of these is a surd, now in this case both of them are surds, this term here is also going to be a surd, and so we shall need to square again. So squaring once is not going to get rid of the square roots entirely. We're going to need to square twice. So that's just to give us a sense of direction as we solve this problem. So if I square from the jump, I'm going to have the square of the first term, which is just 3 to the power x plus 1 plus 2. I want to bring in the square of the last term as well, so plus 3 to the power x minus 1, and then minus twice the square root of the product of the two terms under the square root. So 3 to the power x plus 1 plus 2 times 3 to the power x minus 1, and I equate this to 4. This is true because root a times root b is the same as root ab. So this is true. Now we can simplify what we have on the left-hand side without the term that is without the surd, because I have a term in 3 to the power x here and 3 to the power x here. Now 3 to the power x plus 1 is just 3 to the power 1 times 3 to the power x. This is from the laws of indices. And then I have a 3 to the power x, and then I have 2 minus 1. 2 minus 1 is 1. And this is the same as 2 times the square root of that. Now I could also expand what's under this square root. This is going to be 3 to the power 2x plus 1 plus 2 times 3 to the power x minus 3 to the power x plus 1 minus 2. That's whatever is under the square root, and I'm equating this to 4. Further, going to simplify everything that we have here. So I have a 3 times 3 to the power x plus a 1 times 3 to the power x. That's going to be 4 times 3 to the power x. And then I have a 1 here. I have a 1 and a 4 here. So if I subtract 4 from both sides, this is going to be 1 minus 4, which is going to give me a 3. Now I could decide to take the term with the surd to the other side so that it's on the other side alone. It's going to be 2 times the square root of 3 to the power 2x plus 1. And now here I have 2 times 3 to the power x, but then we have seen that 3 to the power x plus 1 is the same as 3 times 3 to the power x. So 2 times 3 to the power x minus 3 to the power x plus 1 is going to be minus 3 to the power x, because you have 2 minus 3 multiplied by 3 to the power x. And then I'm going to have this minus 2. Now at this point, I can square both sides, so I'm going to do just that. So I will square. And then when I square, I'm going to use the same expansion. So this is going to give me 16 times 3 to the power 2x. Now, why is this 2x? Because I'm going to have 3 to the power x squared. So in that case, you multiply the powers x times 2, which is 2x. Minus 2 times this. That's going to be minus 24 times 3 to the power x. And then plus 3 squared, which is 9. On this side, I'll have 4 times 3 to the power 2x plus 1 minus 3 to the power x minus 2. Sorry, yes, minus 2. Now, it helps us actually, if instead of writing this as 2 to the power x plus 1, 3 to the power 2x plus 1 rather, we write this as 3 times 3 to the power 2x, as you're going to see going forward, because what we're going to get actually is a quadratic equation, and then we'll have to solve that quadratic equation. So if we collect like terms, of course, if you simplify this, this is 12 times 3 to the power 2x minus 4 times 3 to the power x minus 8. So if we collect like terms, we're going to have 4 times 3 to the power 2x minus 20 times 3 to the power x plus 17 is equal to 0. And now this is our quadratic equation. And for those who it's not clear to see, this is exactly the same as 4 times 3 to the power x squared minus 20 times 3 to the power x plus 17 is equal to 0. So it's a quadratic, and the term we're solving for, the variable we're solving for is 3 to the power x. And so at this point, you can use the quadratic formula because you can't really factorize this. So using the quadratic formula, I'm going to have 3 to the power x is equal to negative b. In this case, my b is negative 20. So that's going to be 20 plus or minus the square root of b squared. That's going to be 20 squared minus 4 times a times c. And my a and c are 4 and 17 respectively, out of 2 times a, which is 4. And when you simplify this, you end up with 5 over 2 plus or minus root 2. I've really jumped to simplification of this because of time, because we have a number of questions. But this is quite simple here. You have okay, let me explain. So we have 20 plus or minus the square root of 128 divided by 8. But 128 is the same as 64 times 2, right? So this is the same as 8 root 2, because you have root 64 times root 2. And then this actually gives us the 5 over 2 plus or minus root 2. So that's what 3 to the power x is. Now, if that's what 3 to the power x is, then what's x going to be? So we have two scenarios. When 3 to the power x is equal to 5 over 2 plus root 2, then if I take the logarithm on both sides, I have log of 3 to the power x equal to the log of 5 over 2 plus root 2. And so because of the laws of logarithms, this becomes a multiplier. So x log 3 is equal to the log of 5 over 2 plus root 2. So x will be the log of 5 over 2 plus root 2 divided by the log of 3. We've been asked to express our answer in the simplest form. So this is the simplest form. You can leave this answer like this. And this is for the case when we have plus root 2. So in 3 out of it, 3 to the power x, sorry, is equal to 5 over 2 minus root 2. You have to check that these are actually positive, not negative, sorry, because 3 to the power something can never give you a negative. So you have to confirm that this is greater than 0, and this is greater than 0. The first one is obviously greater than 0 because it's an addition of two positive numbers. But the second one is maybe not so obvious, but it's clearly greater than 0, so we're allowed to do something like this. So the log of 3 to the power x is equal to 5 over 2 minus root 2. And then we come up with the same thing. X will be the log of 5 over 2 minus root 2 divide by the log of 3. So that's to the solution to these. Um, yeah, okay, so another thing you have to check is that you probably have to ensure that this is positive as well. 3 to the power x minus 1 has to be greater than 0. Otherwise, we're going to get into a situation with complex numbers. And yeah, I don't think we can guarantee that then our solution will still be valid. So now, if we check just that means we don't just need 3 to the power x to be greater than 0, we need it to be greater than 1. Now, the first one is obviously greater than 1, like I had said, because it's 2.5 plus root 2. The second one is 2.5 minus root 2. And yeah, that's just greater than 1, 1.08. Yeah, so yeah, both solutions work then. Are there any questions? If there are no questions, then we can proceed to the next question. I think this is pretty straightforward. Or once you are done with the squaring and you know your logarithms, then everything is pretty much just follows naturally. You just have to make sure that you check with all the conditions and constraints that are brought about by the logarithms and by the surds that are involved. So we can move to the next question if there are no uh, inquiries about that. Okay, so we are going to do question 2 now. And question two reads the root of the quadratic equation z squared minus 4 plus 2i times z plus 3 plus 4i is equal to 0 are alpha and beta. Find alpha and beta in the form a plus bi and represent these roots on an Argand diagram. Find the area formed. Find the area of the triangle formed by the origin, alpha and beta. Now, the easiest way to solve a quadratic equation is to really just use the quadratic formula. And so using the quadratic formula is exactly what we're going to do. So z squared minus 4 plus 2i times z plus 3 plus 4i is equal to 0 is the quadratic equation that we're dealing with. And yeah, you could decide to use sum of roots, product of roots, but it's really just going to lead you back to this quadratic equation. If you say that, oh, the sum of the roots is this term here, and the product of the roots is this, it's simply just going to lead you back into solving this quadratic equation. Yes, and if you decide to introduce, to say, let alpha be maybe a1 plus b1i and beta to be a2 plus b2i, then you're just going to introduce more unknowns and you don't have enough equations. Uh, you don't have enough equations to solve those because there'll be some products as well, so it becomes pretty complicated. So the easiest way to go about it is to use the quadratic formula. And so in this case, I'll have z is equal to negative b, which in this case is 4 plus 2i, plus or minus the square root of b squared minus 4ac. B squared is 4 plus 2i squared. There's a negative in there, but when you square, it's implied that, uh, it will become positive. Minus 4 times a is 1 times c, which is 3 plus 4i. And all this is divided by 2a, and our a is 1. So this becomes actually pretty easy to work with. This is plus or minus the square root of, when we square 4 plus 2i, we get 16 plus 4 times 2 is 8, so plus 16i. But then when you square 2i, you get minus 4. And this is minus 12 when you multiply it by 4, minus 12 plus 16i. So all this divided by 2. Now you realize that what happened is that under the square root, everything is going to go away, because we have a 16 minus a 4, which is 12, and then we have a minus 12, so that's 0, and then 69 minus 69. So we have 4 plus 2i plus or minus 0, which is square root of 0, which is 0, out of 2. And so this is just 2 plus 2 plus I. We have a pretty nice situation here, because if we didn't have a square root of 0, then we'd have to actually go ahead to compute the square root of those complex numbers. And that's not something that doesn't take it doesn't take a short time. So that's something that will take us some time. The question is already pretty long if you look at all the things that we need to do. But what this means, if the discriminant is 0, that means we have repeated roots. And whatever is under the square root here is the discriminant. And so that means that this is actually a repeated root. And therefore, alpha is equal to beta is equal to 2 plus I. So that's our alpha and that's our beta. Now, how do we represent these roots on an Argand diagram and find the area of the triangle formed by the origin alpha and beta? Well, this is not hard. So on an Argand diagram, we have this as the real axis and this as the imaginary axis. The origin is actually the complex number 0, and 2 plus I would be somewhere here. So we have something like this. But remember, this is alpha and this is also beta at the same time. So the area formed by the triangle there, this triangle actually is degenerate because it's just a line. And therefore the area formed by the triangle, the area of the triangle formed by the origin alpha and beta is going to be 0 because it's just a line. Yeah, it's not your everyday question, but that actually is the answer. Any remarks or comments or questions on this? Or we can move to the next. Okay. Seems everything is going smoothly, so I will move to the next question, which is question 3. And so for question 3, we've been asked to factorize p of x completely into linear factors, given that p of x is that polynomial there. It's a quartic polynomial, meaning the highest power of x in that expression is 4. In other words, it's the degree of the polynomial is 4. So we've been asked to factorize completely into linear factors. Now, just by looking, the thing is for quadratic polynomials, if we have something like this, x squared plus ax plus b, we use the formula of sum and product, where I say, oh, we have b as the product and a as the sum, so we look for factors of b that will give us the corresponding sum. However, for a quartic polynomial, it's not that straightforward. And so what we have to do is actually test for the factors of the constant term. Now, you have to test both the positive and negative factors of a constant term to be able to get a root. A root is a value of x, which when we substitute into the polynomial will give us a 0. So I'm going to test plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. How many do we have to test? Now, you could decide to test all of them until you get all the 4 that would actually give us give us a 0. But there's first of all no guarantee that that from these we can get 4. It could be something that you could maybe get and a half, but okay, there's no number here, so then that option is sort of ruled out. But in not all the time you'll get all the roots from the factors themselves. That's the point I'm trying to make. But as long as there are real roots, then one of the roots will have to be a factor of the constant term. So our aim is to test and get at least 2, because even if we got 1, we would still have to, we would remain with a cubic equation. If we divide a cubic expression, a cubic polynomial, because if we divide our quadratic polynomial by a polynomial of degree 1, then we'll remain with a polynomial of degree 3. So we want to divide it by a polynomial of degree 2, so that we remain with a polynomial of degree 2, which is a quadratic polynomial. And we know how to factorize quadratic polynomial. Now I'm speaking a lot, so let me actually do what I'm saying. So I'm going to try out P of 1. P of 1 is 1 to the power 4 plus 2 times 1 to the power 3 minus 7 times 1 squared minus 8 times 1 plus 12. And if you work this out, this is 1 plus 2 minus 7 minus 8 plus 12. That's 15 minus 15, which is 0. What does this mean? This means 1 is a root of p of x. And if 1 is a root of p of x, that means x minus 1 is a factor of p of x. It's the relationship between roots and factors. So if a is a root of a polynomial, then x minus a is a factor of that polynomial, which means that if you divide the polynomial by this, you should get no remainder. That's what it means. And so now we have got a factor. So if we wanted, we could divide p of x by x minus 1, and then we'd remain with a cubic polynomial. But still, for a cubic polynomial, we can't just look at it and be able to tell what it factorizes into, because there's no sum and product formula as well. So it would help us if we actually got another root. So you could try p of negative 1, but just by looking, I think you can see that p of negative 1 is not going to work. You have negative 1 to the power 4 plus 2 times negative 1 to the power 3 minus 7 times negative 1 squared minus 8 times negative 1 plus 12. And this doesn't give us a 0. So therefore, you could simplify that. That doesn't give us a 0. So p of negative 1 is negative 1 is not a root, so that doesn't help us. So we could move to the next. We could try out 2. We try out 2. This is going to be 2 to the power 4 plus 2 times 2 cubed minus 7 times 2 squared minus 8 times 2 plus 12. It simplifies to 16 plus 16 minus 28 minus 16 plus 12. And I think if you compute that religiously, it actually comes to a 0. So that is 0. So that means 2 is a root of p of x. And if 2 is a root of p of x, that means that x minus 2 is a factor of p of x. So now we have two factors. And if two we have two independent factors, so x minus 1 and x minus 2, then therefore their product, x minus 1 times x minus 2, is also a factor of p of x. Yeah, so this is how it works for polynomials. It's not necessarily how it works for numbers, but for polynomials, if x minus 1 and x minus 2 are both factors of p of x, then their product will also be a factor of p of x. So that means when we divide p of x by this, we should not get a remainder. And so that's exactly what we're going to do. We're going to divide x to the power 4 plus 2x cubed minus 7x squared minus 8x plus 12. We're going to divide this by the product of x minus 1 times x minus 2, which is when you expand x minus 3x plus 2. So we use long division. It's the most straightforward way, but there are a few other ways you could use, but long division is pretty simple to use. So let's do that. So you divide x to the power 4 x to the power 4 by x squared. That's going to give you x squared, and then you multiply x squared by the divisor. It's going to give us x to the power 4 minus 3x cubed plus 2x squared. And then you subtract this from what we have above. And so we're going to remain here with 5x cubed minus 9x squared minus 8x plus 12. Then we divide again the leading term here by the leading term there. So 5x cubed divided by x squared, that's going to give us 5x. When we multiply that by the divisor, we're going to get 5x cubed that's minus 15x squared, I think, plus 10x. And then we're going to subtract this from what we have above. And that's going to leave us with 6x squared minus 18x plus 12. And this actually perfectly divides. Uh, the divisor perfectly divides this because you're going to get 6x squared minus 18x plus 12. And so indeed there is no remainder, which indeed tells us that that x minus 1 times x minus 2 is indeed a factor of the polynomial. And so what does this mean? It means our polynomial, it's quite a lot to write. So let me just write p of x. P of x is actually equal to x squared minus 3x plus 2 times x squared plus 5x plus 6. We know what the first term factorizes into. This is x minus 1 times x minus 2. And here you could actually use, the sum and product for quadratic polynomials. And this is going to give you x plus 2 times x plus 3. And so now we have factorized p of x completely into linear factors. So this is part A of the question that we're asked to do. Part B is completely different. So I want to ask if there are any questions here. I could answer them. If there's anything that wasn't maybe properly explained, I could go through it again before we get into the bit of partial fractions. So if you have a question, you could type it in the chat or raise your hand. We're not allowing people to unmute because of possible interruptions. Okay, so Crystal has asked that I redo. I'm just going to go over the explanation again of what we're doing here so that I can iron out any inconsistencies or um, sources of doubt. So the question asks us to factorize. Sorry, the question asks us to factorize p of x completely into linear factors. Linear factors are like what we have here in our answer right here. Factors of degree 1. In other words, the highest power of x in a linear factor is just 1. So it's either x plus something or x minus something. A linear factor is of the form ax plus b, where a and b are constants. So this is what we want to have. in all our linear factors here, the value of a is 1. So it's just x minus something or x plus something. And that's actually expected because here we have a 1 here. So that actually makes sense. Yeah. But the b is changing. So I have -1, -2, +2, and +3. But this is what we want. We want to factorize it into linear factors. Now, because the degree here is 4, we expect to actually have 4 linear factors. Because what happens is that the sum of the degrees in the product should be equal to the degree in the degree of the polynomial itself. So it's like if you have this sort of flows from the law of indices. If you have x to the power 2 times x to the power 3, this is actually going to be x to the power 5. The degree here is the sum of the degrees in the product of those two terms. So it's something like that. So if we have a degree 4 polynomial, we expect uh four linear four linear factors because of that. Now, like I said, to factorize this, okay, been told the figures are too small, so I'll try to write bigger. But yeah, so like I had said, to factorize this polynomial, we do not have a particular sort of like formula. Like for it's easy to factorize a quadratic polynomial because we know that thing of the sum is this, the product is this. So then we can get the factors of the constant term that when you multiply them, when you add them, you actually get the required sum. However, for a quadratic polynomial, we can't exactly just do that. We have to first get some roots. And why do we get roots? Because when we get roots, we can get factors. Like we did here, we got x minus 1 as a factor when 1 is a root. Because when 1 is a root, x minus 1 is a factor. This comes from remainder theorem. Uh, and the simplest way I can state this is that if you're dividing p of x by the polynomial x minus a, for example, uh, there's going to be a remainder here. Remainder is usually a constant term there. But if I'm dividing p of x by q of x, by x minus a, q of x is going to be my quotient, and r of x is going to be my remainder. Now, when the remainder is 0, then we say that x minus a is a factor of p minus x, just like when you're dividing 5 by 2. This is 2 times 2 plus 1. The remainder is not sorry, not like this. Like this. The remainder is non-zero, therefore 5 is not divisible by 2. However, you have 4. 4 is 2 times 2 plus 0. So because we have that 0 there, then we can say that 2 divides 4 perfectly, or 4 is divisible. 4 is divisible by 2. So from this right here, when we're dealing with polynomials, if I substitute for a, right? If I substitute for x with a, p of a is going to be, this whole thing is going to become 0 because you have a minus a, which is 0 times q of x. And then you're just going to be left with r of a, which is when you substitute a into the remainder expression. Now, if this is equal to 0, right, then that's going to imply that x minus a actually divides p of x. This is how you write divides p of x. But what we're trying to say is that p of x is divisible by x minus a. And so when p of a is equal to 0, in other words, when a is a root of the polynomial, then x minus a is a factor of the polynomial, which is exactly what we're using here. Some hands have been raised. Rose and Ngulocha. So I'm going to ask Rose first to unmute, and then I'll ask Theodosia to unmute afterwards. Maybe you could ask your question.
Um, we had a degree of 4
Yes.
expression P. So like, does the degree of the equation show you how many factors you're supposed to come up with?
Yes, it does. It shows you how many linear factors it shows you like the maximum number of linear factors you could get. Now, the thing is, sometimes, and when you learn about complex numbers, I don't know if you've learned complex numbers. Have you?
Not really, not yet.
Yeah, but when you're solving some cubic equations, you could come across situations in which there are like two complex roots and only one real root. So in such a scenario, you would get maybe something like x if you're factorizing something that's cubic, right? So maybe x cubed minus something plus something. You end up with something like x minus 1 and then times x squared plus something plus something. And then when you actually look for the roots of this, they are complex. So, but what you have is that the degree of this is 1 and the degree of this is 2. And that sum of those degrees should give you the degree of the polynomial, of the original polynomial which you're trying to factorize. So the point there is that the degree of the polynomial you're trying to factorize will be the sum of the degrees of the factors into which you break it down. Now, because the question told us to factorize into linear factors of degree 1, that means we should end up with four linear factors.
Okay, so if we had a polynomial of a degree maybe 7, that means that we find like
Yeah, so you'd
4
have to
factors.
yeah, so
Five.
if it was degree 7, then you if and they were all linear, for example, you could try just expanding this and see what you get. You get a polynomial of degree 7, but here it's a repeated root. So yeah, but if you did that, then you'd get x to the power 7, a term in x to the power 6, and so on and so forth. But these are actually 7 factors, because this is x minus 1 times x minus 1, 7 times, right? And so this is actually the degree of each of these is 1, and there are 7 of them. So 1 plus 1 plus 1, 7 times is 7. And that's actually the degree of the polynomial you get when you expand. So that rule sort of like holds that the sum of the degrees of the factors will be equal to the degree of the polynomial that you're trying to factorize. But you may not always have linear factors, but just know that the sum of the degrees will always be equal to the degree of the polynomial that you're factorizing.
All right. Thank you.
Yeah. Uh, Dear Don, your hand was up. Now it's no longer. I don't know if you had your question is answered. Yeah. So, in the interest of time, let me try to move a bit faster. CC. Okay.
Excuse me, sir.
Yes, please.
I want you to repeat for me this division part. I've not understood it.
The long division part.
Yeah.
Okay, I'm going to do that. Let me first ask this person find out what the other I don't know if I'm pronouncing her name wrong.
Yes, sir.
Yes, please.
Thank you for the great work done. I was
Yes.
asking, how do you understand that this one you need to put there one or you need to put there two in order to factorize completely to get factors? I mean,
Okay. So to choose the factors, we the way the expansion works, even just by looking at what we have got at the very end, you can see that
mm,
if you are to expand this, yeah, these constant terms would end up multiplying each other. So you see, if you're to expand this, remember you have to multiply everything by everything. So you'd have that this -1 multiplies that -2, with the positive 2 and the positive 3, and eventually we get this 12. So that means whenever we're trying to factorize a polynomial of degree 3 or higher, our key is always going to be to look at the constant term. And we shall suspect that the roots of this polynomial will always be that one of the factors, at least one of the factors of the constant term will give us a root. Now you have to check for positive or negative. So which is why we first listed the factors of 12 here. Plus or minus 1, plus or minus 2, plus or minus 3. Now there's no way to just look and tell unless like you see things very fast. You make the computations very fast in your head. But we just try, right? So now you see we tried for 1 and it worked out, but for negative 1 it didn't work out, so we didn't consider it. And then for 2 it also worked out as well. Now we decided to take only 2 because once we take 2 we can get a quadratic factor, and then when we divide the quartic polynomial by a quadratic factor, we know we shall get a quadratic factor, and we know how to factorize quadratic expression.
Oh, all right.
Yes.
Thank
Okay.
you.
Yeah. So now, CC, to answer your question on how the division is done, again, I was still trying to explain the first part, but the idea, I think, has been said. Look for factors of the constant term, try them out. From the roots, you get the factors. Then now, because we have that x minus 1 divides p of x and x minus 2 also divides p of x, then that means their product should also divide should also divide p of x. It actually also, I said it doesn't work like that for numbers, but it does as long as the two factors have nothing in have no common. Okay, their greatest common factor is 1. For example, if they tell you that a number is divisible by 2 and it's also divisible by 3, then that means it must be divisible by 2 times 3, which is 6. Because if it's divisible by 2 and divisible by 3, then it must be divisible by the product of the two of them, which is 6. Yeah, so it's a similar thing applying here actually. And so now the way the division works, Cici had asked about the division, is that you look at the leading terms. This long division is not different from long division of numbers. You look at the leading term here. So you look at x to the power 4 and x squared here. Now those are the ones you're going to be dividing. Just like here, we looked at 5x cubed and x squared again. And then here we looked at 6x squared and x squared. So you divide x to the power 4 by x squared, you get x squared, and then you multiply x squared by all this, right? And that product is what we have right here. When you multiply x squared by x squared minus 3x plus 2, it's what we have here. And then we subtract it from the dividend, which is our polynomial p of x. Now, when you subtract, you have to be careful because there's a minus sign outside in there. So you're going to have 2 minus minus 3, which is 5, not just, 2 minus 3. 2 minus minus 3 is 5, and here you have minus 7 minus 2, which is minus 9. And then you bring down the other terms, which is minus x plus 12. And then you do the division again. Now, again, like I said, look at the leading term. The leading term here is 5x cubed. You divide 5x cubed by x squared. And when you do that, you get 5x. So now you bring the 5x, multiply it by the divisor again, and then you subtract that product from what you were dividing. Dividing x squared minus 3x plus 2 by. Yeah, and then you repeat the process until you're left with nothing. So you repeat this until the power of x here is less than the power of x here, but we don't even have a remainder. So yeah, there's nothing more that we can do. I hope that answers you, CC. It's not very different from long division of actual numbers, if you remember how that works. Yeah. I'm going to move to part B because of time. Part B tells us to hence express 1 over p of x in partial fraction. Now, this is not hard actually. It's actually pretty straightforward if you know how to express. If you have done questions on partial fractions, then this will actually be very, very straightforward because 1 over P of x is simply going to be 1 over x minus 1 times x minus 2 times x plus 2 times x plus 3. And now we say that this is equivalent to a out of x minus 1 plus b out of x minus 2 plus c out of x plus 2 plus d out of x plus 3. And so our task is to find the coefficients or constants a, b, c, and d. Now, of course, you realize that if we were to put all this under the same numerator, which is the product of all the factors, the numerator on the right-hand side will be a to the power x minus 2 times x plus 2 times x plus 3 plus b times x minus 1 times x plus 2 times x plus 3 plus c times x minus 1 times x minus 2 times x plus 3, and then plus d times x minus 1 times x minus 2 times x plus 2. And we're equating this to 1. I've skipped the step because of space and time. The step about first putting this out of the product, but it's also going to be out of the same product on the left-hand side, so we can move forward with that. Now, the easiest way to find all these coefficients is to substitute different values of x. So you could start with when x is 1, and when x is 1, on the left-hand side, you'll still have a 1. On the right-hand side, everywhere you see an x minus 1 is going to vanish to 0, that whole product. So the ones with b, c, and d will vanish to 0, and you'll only be left with a times 1 minus 2, which is negative 1, times 1 plus 2, which is 3, times 1 plus 3, which is 4. And this is actually negative 12a. What that means is that a is equal to negative 1 over 12. And then you keep on doing that. So when x is 2, still on the left-hand side, you'll have a 1. On the right-hand side, you'll have the term with b alone, because everywhere there's an x minus 2, so that's going to vanish to 0. You have 2 minus 1, which is 1, 2 plus 2, which is 4, and then 2 plus 3, which is 5. So this is actually equal to 20b, and therefore b is equal to 1 over 20. The next is 3. Sorry, not 3. We keep on substituting values of x that are going to be useful to us. So instead of 3, we're going to do negative 2. We'll have 1, and where only the term with c will remain, because all the others have an x plus 2. Negative 2 minus 3 is negative 3. Negative 2 minus 2 is negative 4. And then negative 2 plus 3 is actually positive 1. So it's going to be 12c. And therefore, c is going to be positive 1 over 12. And then when x is equal to negative 3, we'll only have the term that has d in it. And so I'll have negative 3 minus 1, which is negative 4. I'll have negative 5, and then negative 3 plus 2, which is minus 1. It's going to be negative 20 times d. Therefore, d is equal to negative 1 over 20. Okay, so this is the easiest way to get the coefficients. If you decide to expand and then equate equate coefficient, you'll end up with 4 simultaneous equations. And then the easiest way to go about that is row reduction. Otherwise, then you've put yourself in hot soup unnecessarily. Yeah. So the easiest way is to just substitute values of x that will make our work easy, really. And that's the way to go. So once you have this, we have our coefficients. Therefore, 1 over p over x actually equal to negative 1 over 12 out of x minus 1 plus 1 over 20 out of x minus 2 plus 1 over 12 out of x plus 2 plus negative 1 over 20 out of x plus 3. you wanted, you could simplify this and say, okay, this is 1 over 12 times 1 over x plus 2 minus 1 over x minus 1 plus 1 over 20 times 1 over x minus 2 minus 1 over x plus 3. If you just wanted it to look neat. But yeah, that's the solution. There seems to be comment in the chat. Okay, is it necessary to carry out long division? What if I just try the different values of the factors of 12 until I get the 4 factors? Well, yes, you could have done that right here. So you could have decided, oh, I've got 1 and 2. You try -2, it will work as well. And then after trying -2, if you actually, from there, if you just divide by the cubic factor, that's the product of x minus 1, x minus 2, and x plus 2, then eventually you'll actually just get x plus 3 straight away. The thing is that, like I said, it's not always guaranteed that all the 4 factors will actually come from the factors of the constant term. In this case, yes, it's true. So eventually, when you actually reach -3, you'll have got all the factors that are required. But as mathematicians, we want to be smart. So we don't want to look like we are guessing. And so in this question, really, we have to do some, not guesswork, but some sort of try and error. And we want to limit the amount of try and error that we do. Of course, if you try and error up to a certain point, you'll eventually get the answer, and maybe even quicker than someone who does this. But to show that we actually know what to do in a situation whereby this try and error may not always work, it's better to do something like this, which is why I would recommend doing this for this particular case. But yeah, if you actually try out the factors of 12, you'll get the answer. It's just that it may not always work. It may not always give you all the factors. Yeah. Yeah. So at this point, I'm going to let the presenter for the next question take over, and then yeah, we'll continue from there.
Okay, good morning, everyone. I hope you can all hear me. Someone can confirm with a thumbs up. Okay. Yeah, so we're going to number 4. It's a question from logarithms, and more particularly logarithmic inequalities. And it reads, find a set of values of x for which log of x squared minus 5x plus 7 to the base of 0.5 is less than 0. It's okay. Yeah, so for this question, we should take note of the fact that our base is less than 1. And every time we're working with logarithmic inequalities, where the base is less than 1, we reverse the sign. So the sign here is going to change to greater than as you're getting rid of the log. So it means that you're going to have x squared minus 5x plus 7 being less than 0.5 raised to the power 0. That's one of the tricky parts of that question. Okay, so we shall have x squared minus 5x plus 7 being less than that. Any number raised to the power 0 is always equal to 1. Okay, and simplifying that by taking the 1 to the left-hand side, we shall have x squared minus 5x plus 6 being less than 0. Okay, the function on the left-hand side can be factorized. Yeah, so we shall have x squared minus 3x minus 2x plus 6 being less than 0, which will give us x minus 3 into x minus 2 being less than 0. Okay, so at that point, we need to find the values that are going to satisfy that condition, the values of x that are going to satisfy that condition by doing some sign analysis. So we shall draw a simple table. We shall have the interval x minus 2, x minus 3, and then the product of x minus 3 and x minus 2. So we are going to test out values of x when x is less than 2, then when x is between 2 and 3, so 2 less x less 3, and when x is greater than 3. Okay, so when x is less than 2, I can choose a value such as 1. If I put 1 there, I'll end up with a negative. So the sign will be negative in sign analysis. Then when x is between 2 and 3, sorry, when x is greater than 2 but less than 3, I can choose a value such as 2.5. So 2.5 substituted here, I'll get a positive result here. Then when x is greater than 3, I can choose a value like 4. So 4 put here, 4 minus 2, it gives us a 2, which is positive. Okay. Then for this second column, when x is less than 2, I can choose 1. 1 minus 3 gives me a negative result. So we shall have a negative there. And then when x is between 2 and 3, I can still use 2.5. 2.5 minus 3 gives me a negative. Then when x is greater than 3, I can choose a value such as 4. 4 minus 3 gives me 1, which is positive. Okay, then I get the product for each of those values of x. So when I multiply a negative times a negative, I'll get a positive product. When I multiply a positive and a negative, I'll get a negative product. And when I multiply a positive and a positive, I'll get a positive product. But what was the condition? The condition was that the product of x minus 3 and x minus 2 must be less than 0, which means that the product is negative. And when I look at my table as testing, I can get a negative product in this case here, where my value of x is between 2 and 3, which means that the answer to that inequality would be 2 less than x less than 3. So values of x lie between 2 and the values of x that can satisfy that inequality lie between 2 and 3. Which is our answer. Yes, you have to test for. You have to find out the values that satisfy that, where they lie. You have to first, you have to always find out the range in which those values lie. Okay, that's our question 4. Does anyone have a question? Okay, I don't see any hand raised. Oh, Rose, you can ask a question. Yes, Rose.
My question is, okay,
Mhm.
can we do an example? Can you do an example of a table in case we had less than or equal to 0? Because I want to see how it looks like. Okay, I want to know.
Less than or equal to 0.
Yeah.
So the condition is you want values of x that are less than or equal to 0. Okay. So we have x minus 3 and x minus 2 being less than or equal to 0. Yeah, so in that case, you're looking at, okay, the values you can have are x being less than 2 or x being between 2 and 3. Now realize that in the condition where you have x being less than 2, you are going to cater for that 0 because the less than 2 means that everything less than 0 is being catered for in that case. So it would be the same thing. X less than 2, x between 2 and 3, and x greater than 0. Those are ranges we test for. Nothing else changes. Yeah, everything else remains the same. Okay. Yes, Emanuela? Emanuela, I can ask a question. Okay, I think she's not able to hear us. Any other question? Okay. So we'll move to number 5. Oh, someone is saying, could you explain the first step of the solution? Okay, in the first step, I changed the sign because the base is less than, the base we have over here is less than what? Is less than 1. So every time you have a base that's less than 1, you change the sign of your inequality. Why? For logarithms where the base is less than 1, the logarithm is a decreasing function. Let us look at some examples. If I have maybe log of 2, log of 2 maybe So every time I have a base that's greater than 1, the logarithm is an increasing function. Okay, we can use 2. For example, if I have 2 power 0, I will have a 1. And if I have 2 power 1, I'll have a 2. 2 power 3, I will have an 8. So I realize that for positive values, the logarithm just gets bigger. But if I have a negative value, for example, 0.5, a negative base, and I have 0.5 and I raise it to the power 1, I'll end up with 0.5. But if I raise 0.5 to the power 2, I realize that it's going to just decrease. So it becomes 0.25. Then 0.5 raised to the power 3, I think you'll end up with something like 0.125. Realize that for bases less than 1, the logarithm just keeps on getting smaller. So if the base is positive, as you increase the powers, you end up with, okay, the more you increase the powers, the bigger the number gets. But for bases less than 1, the more you increase the powers, the smaller the number gets. So it's like a reverse. That's why I also reversed the sign in our step. So our rule is that every time you have a base that's less than 1, you inverse the sign for logarithms. Yeah. Okay. Any other questions? Let me check the chat. Okay. I'll be able to answer the questions in the chat because of time. So let us move to the next question, which was on permutations and combinations. And it reads, a committee of 5 is to be formed from 6 participants and 4 observers. And part A says, in how many ways can this be done? There must be a majority of participants on the committee. So the condition is that you're going to form a committee of strictly 5 people, but out of those 5 people, you must have more participants than observers. Okay. So we have participants. So we have 6 participants and then 4 observers. And you want to form a committee. Oh, can you see my screen? I'm still sharing. I think we should be able to see it. Okay. So out of the 6 participants and 4 observers, I want to form a committee of 5 people. And the condition is that the majority of the people on that committee must be participants, which means that in any case, in any scenario I'm taking, I should have more participants than observers. Okay. But my committee must be having 5 people. So I can start with a scenario where I am choosing, where out of 6 participants, I'm choosing 5 observers. So out of 6 participants, I'm choosing 5 people. And then out of the 4 observers, I'm choosing none because I want a committee of strictly 5 people where I have more participants than observers. So that's the first scenario. Then I can keep on decreasing the number of participants while increasing the number of observers, but putting into mind that the number of participants must not go below the number of observers. Yeah, which is the condition we had in part A. So that's the first way of forming the committee. Or out of the 6 participants, I can choose 4 people. And then out of the 4 observers, I can choose 1 person. The committee still has 5 people. Then out of the 6 participants, I can choose 3 people. And then out of the 4 observers, I can choose 2 people. Okay, now you realize that I can't go beyond that, because if I decrease the number of participants in the next case, I'll end up having 2 participants on the committee and 3 observers. Means that those are the only scenarios I can have for that committee. The committee must have at least 3 participants. In other words, that was the condition. The committee must have at least 3 participants. Okay. So I'll use my calculator to solve that. 6 combination 5 times 4 combination 0 gives us 6. And then 6 combination 4 times 4 combination 1 gives us 60. And 6 combination 3 times 4 combination 2 gives us 120. And if I add up those, I'll end up having 186. So there are 186 ways in which I can form that committee of 5 people, with a majority of people in the committee being participants. Okay. Then the second condition was that how can I form a committee of 5 people from 6 participants and 4 observers if 2 specific observers refuse to serve together? Yeah, how many combinations can I have? How many ways can I form that committee? Okay, that was part A. Then part B. So realize that part B is totally independent of part A, which means that in part B, I just want to form a committee of 5. I don't care about the number of participants and number of observers, just like we had in part A. The condition is that if 2 specific observers refuse to serve together. So here, the easiest way to have it done is to have the total number of ways possible. Yeah, the total number of combinations the total possible number of combinations I can have without restrictions. So total unrestricted combinations of having that committee minus total combinations if the 2 observers are included together. If 2 observers, if the 2 observers that didn't want to sit together are included together, Yeah, so I have a pool of 10 people from the 6 participants and observers, but out of those 10 people, I want to form a committee of 5. That's what I mean by total unrestricted combination. So I'll have 10 combination 3, which is combination 5. Out of 10, I want to form a committee of 5. And that will give me the total unrestricted combinations. Out of the 10 people, 6 participants and 4 observers, I want to get a committee of 5. Then minus the case where I'm having a combination where the 2 people in the question that didn't want to serve together are serving together. That's the easiest way you can solve this out. So in that case, it means that I've already got those 2 people together. So 2 positions are fixed. and I'm left with only 8 people from which I can choose from. So out of the 8, I want to choose 3 people to add to the 2 who are already fixed to form my committee. So 10 combination 5 minus 8 combination 3. I'm removing the 2 people. The 2 people are already on the committee. I'm taking the scenario where they're serving together. So I've removed the 2 people from the group of 10, which means that I'm left with 8 people from whom to choose. And out of those 8, I just want 3 to go and join the other 2. Yeah, and why am I subtracting? Because the scenario I'm considering in this case is a scenario where the people are serving together, yet the question wants me to consider those 2 people refusing to serve together. Yeah, so I'm subtracting this from the total number of possible combinations. Okay. So 10 combination 5 will give me 252. And then 8 combination 3 will give me 56. And when I subtract those two, I'll end up with 196 combinations. Which is my answer. Oh, so some people haven't yet studied this topic of permutations and combinations. So they might be conversant with how to get this from their calculator. But I think when you check your calculator, there's a button that reads NCR. Yeah, so there must be a shift somewhere and you should be able to get it. I don't have a calculator here, so I can't tell. But yeah, that's it. Any question regarding that working? Yes, Karen.
Okay, good morning.
Good morning.
So I have 2 things. Number one, the good news is I have a calculator with me. So those who are facing issues, you just go on the division sign. There is that NCR up above it. So it's shift and the division sign, then the C will appear. So you just press the first number up, for example, 10, then shift division sign, then the other number, and you get your answer. So that's my first issue. The second thing is, I'm wondering, part B, I need a little explanation. Again, will you pardon why you're subtracting, please?
Okay. So for part B, I first of all considered forming that committee of 5 out of my pool of 10 people. That's what I called unrestricted combinations. I'm just out of those 10 people, I'm just getting my 5 to form the committee, no restriction. So I did 10 combination 5 out of 10 people. I'm getting 5. That's if I don't have a restriction. But my question has given me a restriction of on that committee. Okay, 2 specific observers refused to serve together on that committee. Is it clear? So I have considered those 2 observers. For this case, where I'm subtracting because I've considered the scenario where those 2 observers are serving together. Are you together? So I've already picked those 2 observers and I've put them together, which means that okay, I've removed those 2, and out of 10, I'm left with only 8 people. Are you together?
Yes.
That's why I'm putting an 8 up here. So I'm going to choose out of 8. Now I've already chosen those 2 people and I've fixed them. And I'm choosing the committee from 8 people out together.
Yeah.
Which means that I'm left with only 3 people to add to the other 2 who have been fixed together, accomplish my committee of 5. So this 8 combination 3 is for the committee putting into consideration that those two specific observers are serving together. I don't know if that makes sense.
Okay, I get. Thank you. Yeah.
Yeah.
For me, it has.
Yeah.
I've understood.
Yeah, and I subtracted from unrestricted minus that condition of those two being together to get what I would have if those two are not serving together. Mm. Okay. Any other questions? I guess that's it for number 5. Yeah, so I'll invite the next discussant to take us to the next question.
I hope you can hear me. Thank you. And very swiftly, we'll be moving to question 6. I've sent links to our WhatsApp groups in the chat, links to our YouTube channel where we'll post the recording in the chat, and also a feedback form in the chat. Please engage with all these links, especially the feedback form on the YouTube channel. If you're not in any of our WhatsApp groups, then you could join them. The links have been sent there. We do a lot of discussions on there, and if there's any information we want to pass, we use the WhatsApp groups to do that. Yeah, so please join and share the links as well with someone who you might think needs them. Yeah, so this is the question that we're dealing with, question 6. We've been asked to express this as a sum of partial fractions by using the substitution u is equal to 5 to the power x. Now, 5 to the power x, we just have to substitute for u. So I'm just going to write this as u plus 1 out of u minus 1 times u squared plus 1. Now the question is, why is this u squared? Well, 5 to the power 2x is the same as 5 to the power x times 2, which is exactly the same as 5 to the power x squared. And so 5 to the power 2x is actually u squared if we take u to be 5 to the power x. Now, to express this as a sum of partial fractions, we have a linear factor in the denominator, and for the second one, we have a quadratic factor, and this cannot be further factorized as long as we're considering real factors. So this numerator here would be bx plus c. So we have a linear numerator when we have a quadratic denominator. So this is going to be u squared plus 1. And then we do what we did for the previous question, really. This is going to be a times u squared plus 1 plus bx plus, sorry, I write bx, but it's supposed to be u. I think it's a force of habit. This is bu plus c multiplied by u minus 1. I'm dividing this by u minus 1 times u squared plus 1. So we equate the numerators. So u plus 1 must be equivalent to a times u squared plus 1 plus bu plus c times u minus 1. Now this is when we substitute. Now we have to be wise when we do this because we have three coefficients that we want to find. So if we can eliminate 2, that would be wise. So I'm going to start with when u is equal to 1. So on the left-hand side, we'll have 1 plus 1, and on the right-hand side, I'll have a times 1 squared plus 1, which is 2a. Okay, let me write this in a separate line. So 2 is equal to 2a, therefore a is equal to 1. So a is equal to 1, Now, what can I eliminate? I can eliminate b if I equate my u to 0. So when my u is 0, on the left-hand side, I'm going to have 0 plus 1 is equal to, now I know what a is. A is 1, so I can substitute for that. It's going to be 1 times 0 squared plus 1 plus, I've eliminated the b, so it's just going to be c times 0 minus 1. Okay, so this is 1 is equal to 1 minus c, and therefore c is equal to 0. So c is equal to 0, and now I can decide to use anything else. I'm going to go with u being -1 because now I have a and c, so it shouldn't be hard for me to get. Shouldn't be hard for me to get b. I just have to substitute for any value of u really, as long as it does not eliminate b. So I'm going to have a -1 plus 1 on the left, and then on the right, I'm going to have a times -1 squared plus 1 plus b times -1. C is 0. My a is 1, so I can actually substitute for those. My a is 1. My c is 0. So I have this, and then times -1 minus 1. So this here I'm going to have a 0, here I'm going to have a 2, and here I'm going to have a 2b. Therefore, my b is going to be -1. Okay, so I have those. So that means that u plus 1 out of u minus 1 times u squared plus 1 should be equivalent to, my a is 1, so 1 out of u minus 1 plus negative u out of u squared plus 1. My c is 0, so yeah, so you could write this as 1 out of u minus 1 minus u out of u squared plus 1. And then, of course, the aim was to actually do this for 5 to the power x. Yeah, so this should give us 1 out of 5 to the power x minus 1 minus 5 to the power x out of 5 to the power 2x plus 1. Yeah, it's as simple as that. I don't think are there any questions really? Okay. Yeah, I think that was pretty straightforward. I'll just say what again, replace the 5 to the power x with u. That means 5 to the power 2x will be u squared. Realize that we have a linear factor and a quadratic factor. So for the linear factor, a constant term in the numerator. For the quadratic one, linear term in the numerator. And then, yeah, do everything you can to find a, b, and c. Next, we'll go to question 7. So for question 7, part B, I'll just say ahead of time that part B is actually would require us to use algebra. Would require us to use a bit of calculus. And because it's supposed to be an algebra seminar, then we're not going to do part B. So we're just going to do part A today. And part A tells us that we should use the method of completing the square to find the width that maximizes the area. Now, if a to the power, a of w is minus 2w squared plus 12w, where w is the width in meters. How do we complete the square? So to complete the square, really, you first factor out this. It's easier when you're dealing with just this is squared. Sorry, it's easier when you're dealing with just w squared and there's no coefficient of it that you're focusing on. So this is going to be w squared minus 6w. Yeah, so realize that this is exactly what we have. Now from here, you can already tell that we expect a maximum because the coefficient of w squared is negative. So that already indicates that we expect a maximum. You realize that for quadratic expressions, when we have the coefficient of the square term being negative, then that will give us a maximum. And when it's positive, we'll have a minimum. And you can see it from the shapes of the graphs as well. This is when we have a minimum. So we have a positive coefficient. So it keeps going positive, but then it has a lowest point. And then when you have it as a negative, it keeps going down, but then you have this when it's negative, so you have a maximum. Okay, so now how do we complete squares? You complete squares by adding a certain term to this, whatever is in the bracket. So now I'm looking at w squared minus 6w. Now, using this expansion again, a minus b squared is equal to a squared minus 2ab plus b squared. So now completing squares, what we assume is that we have this, and then we want to add the b squared, so that eventually our expression can be equal to the square of a minus b. So if you look at what we have w squared minus 6w. So my w is my a in this case. So if my w is my a, that means 2b is equal to 6, and therefore my b is going to be equal to 3. So what do I want to add? I want to add 3 squared. So that's exactly what we're going to do. We're going to add 3 squared. And when we add 3 squared here, for the sake of equality, after I've added 3 squared, we're going to have to subtract it. But then, look, well, there was a negative coefficient here, okay? A minus 2. So basically what we have done is add negative 2 times 3 squared. So we have to subtract minus 2 times 3 squared, which is the same as adding 2 times 3 squared. That part might be a little bit confusing, but you just want to make sure that whatever you've done, you've not changed the equality. So if you look at what we've added to the previous step, we added a negative 2 times 3 squared. So we have to subtract a negative 2 times 3 squared, which is the same as adding 2 times 3 squared. Yeah, and then from here, once we reach here, then we're more or less done. This is the same as minus 2 times this plus 18. There's something in the chat. Okay, someone's asking. Rose, your hand is up.
I'm a bit confused.
Okay.
Like, okay, what I know, when we are completing squares, we get the coefficient, and then we have it, and then we add and subtract. But
Okay.
then,
Okay, so yeah, so that's exactly what we've done. I just described it differently, yeah. So we move from this step. This is minus 2 times w squared minus 6w, right? So the coefficient here is negative 6, right? So you half it, which is going to give you negative 3, right? And then you add and subtract. So you're going to add the square of negative 3. But then here we've added it. So you want to subtract it as well. Within the same bracket, you can do that for the sake of equality, right? And now what this translates to is minus 2 times w squared minus 6w plus 9, but then minus 2 times minus 3 squared. So now I've distributed the minus 2, right? I've done this times this, and then this times the second part here, distribution. All this is exactly the same. What you don't want to Yes, yes. Does that help?
It's okay, I've got it. Yeah, I've got
Yeah,
it. Thank you.
yeah. So what you want to do, there's a question in the chat as well asking about a similar thing, is you don't want to cram that, okay, whenever I'm computing squares, I do this. It actually comes from this right here, right? That you have your A, you're trying to get the B squared. You have your A squared and your minus 2AB, or plus 2AB, depending on the situation. You want to get the B squared to add it so that whatever is there becomes now a perfect square. That's what you're trying to do. So here, when we have W squared minus 6W, all we're missing really to make it a perfect square is a 9. But if we add a 9 there, then we have to subtract it so that we do not change anything. And that's exactly what's going on. Yeah. So once we reach this point, realize that the square of any number is always non-negative. So it's never negative. It's either 0 or positive. And so that means that this term here, because the square has a negative coefficient, then this term here is always going to be, will never be positive. So it's going to be non-positive because you have a negative multiplied by a non-negative number. So this becomes non-positive. And so it's always going to be reducing on 18 unless it's 0. And so I can confidently say that this term here is less than or equal to 18. Yeah, it will never be greater than 18. And equality holds. So this is a neat way to write it. Equality holds when is the area of W equal to 18. Equality will hold when that highlighted term is equal to 0. And it's equal to 0 when W is equal to 3. When, of course, when W is 3, then you see that that whole thing vanishes to 0. So we have found the maximum, the width that maximizes the area, which is 3. And that area is actually 18. Yeah. Any questions on that? Yeah. Okay. There are no questions on that. Then we'll move to question 8. Here we have another quartic equation. Right. So, okay. Seems to be something in the chat. Karen is asking, why is it 3? Let me write that expression right here. So we got that the area is equal to negative 2 times W minus 3 squared plus 18. Now, if you get your calculator and you put this in your calculator, let's say minus 2 times x minus 3 squared plus 18, and then you press cal to calculate. If you calculate when x is 3, you'll get 18. Because when x is 3, this becomes minus 2 times 3 minus 3, which is 0 squared plus, so this is all 0, and you're just left with 18. But for any other number you place in place of x, you'll never get a number bigger than 18. The reason is because for whatever number you put here, whether it's positive or negative, whether this term W minus 3 is negative or positive, you're going to square it. And when you square it, it becomes positive. But now it's positive. When you multiply it by negative 2, it becomes negative. Now, when it's negative, that means you're going to reduce on the 18, right? So because of this negative, right, we know that we're going to have a maximum. That maximum is going to be this free constant term here. And we can only get that maximum when this is 0. Because this term here, minus 2W minus 3 squared, is never going to be more than 0, because you have a negative times a non-negative number, and it will only be 0. So the maximum of this term here, minus 2 times W minus 3 squared, is 0, and it's only 0 when W minus 3 is equal to 0. So when W is equal to 3. That's the bit I'm saying about equality holding. So I was just saying equality, whenever you state an inequality, it's just a fancy way of doing things, but you really don't have to do this. You can just say, therefore, the maximum is 18 when W is equal to 3. But whenever you write an inequality, you're trying to show that, oh, what I've written, the expression that I've written, like I actually wrote here, W minus 2 times W minus 3 squared is always less than or equal to 0. Why? Because this term here is non-negative. Non-negative means positive or 0. So it's always positive or 0. And when you multiply a positive number by a negative number, you get a negative number. So that means that because I'm multiplying -2 by a non-negative number, then I'm going to get a non-positive number. So all this is non-positive. And if it's non-positive, that means its maximum value is 0. And because its maximum value is 0, so I'm saying it's less than or equal to 0. And equality holds, that means I'm talking about the case when it's equal to 0. So when does equality hold? Equality holds when -2 times W minus 3 squared is equal to 0. You solve this, you end up with W is equal to 3. Yeah. So W is equal to 3 is actually the case when we have maximum area. And it's maximum because whatever number you put here that's not 3, yeah, you're always going to be reducing on the 18. I hope that makes sense. Okay, back to question 8. We have another quadratic equation. But in this case, now you could decide to do the other thing that we talked about, which was the factors of 2. Factors of 2 are 1, -1, +2, -2. But there's also a 2 here, so you might need to factor that in. Usually when there's a 2 for quadratic expression, you multiply that 2 by the constant term. So now in this case, so if you were to use that sort of mindset, you'd be looking for factors of 4, which is 1, 2, and 4, but you're looking for the positives and negatives. But is that what we're going to get in this case? Well, let's find out. Now, if you look at this equation, this is a symmetric equation. Symmetric in the sense that if you look at the coefficients of the x's, we have something neat in there. Yeah, we have a 2, sorry. We have a 2, an x, and a 6. Sorry, yeah, 2, a 1, and a -6, and then a 1 and a 2. So I have 1 here, and so 2, 1, -6, and then 1, 2. It's very, very neat. So how do we in general handle equations like this? The way to handle equations like this is we reduce them to a quadratic equation and then solve that quadratic equation. The general way to solve equations like this is to use the substitution y is equal to x plus 1 out of x. And like I said, we're going to convert this quadratic equation to a quadratic equation. So it helps us to know what y squared is going to be. Now, if y is equal to x plus 1 out of x, y squared is going to be, if you just expand this is going to be x squared plus 2 plus 1 out of x squared. So because I'm going to be substituting for the x squared, it helps me to take the 2 to the left so that I know how this is going to work out. So that whenever I see x squared plus 1 out of x squared, I know it's y squared minus 2. Whenever I see x plus 1 out of x, I know it's going to be y. So this is the substitution that's going to help us to solve this quadratic equation. The first step here is to divide by all through by x squared. Divide all through by x squared, end up with 2x squared plus x minus 6 plus 1 out of x plus 2 out of x squared is equal to 0. I think you can see the symmetry coming out because we have a 2x squared and a 2 out of x squared, so that I can write as x squared plus 1 out of x squared. And then I have x plus 1 out of x in there as well. And then minus 6 is equal to 0. So this reduces it sweetly to twice y squared minus 2. Again, we had already prepared for that right here on the left. Plus y minus 6 is equal to 0. So this leaves me with 2y squared. You see there's a minus 4 in there. Plus y minus 4, that's going to be minus 10 is equal to 0. Now you solve this quadratic equation here. 2y squared plus y minus 10 is equal to 0. I know we all know how to do this. So I'm just going to give us the roots to this quadratic equation straight away. You can decide to factorize, use a quadratic formula, whatever method you want, but we all know how to do this. And the roots are y is equal to 2 and y is equal to negative 5 over 2. Now in practice, don't do what I've done. Okay, so don't jump from a quadratic equation to the roots. Even if you're going to use your calculator, at the very least, substitute the values, the coefficients of the quadratic equation into the quadratic formula. And then just you can conclude with the answer straight away. Because there's a method mark there that you're going to miss if you don't do that. So y is equal to 2, and then y is equal to negative 5 over 2. Now, for each case, you're going to solve what x is. So when y is equal to 2, you're going to have x plus 1 out of x is equal to 2. Simplify this, you multiply all through by x, you'll have x squared plus 1 is equal to 2x. So x squared minus 2x plus 1 is equal to 0. And when you solve this, this is actually exactly x minus 1 squared is equal to 0. And so x is equal to 1. This is a repeated root. Important to say that it's a repeated root because for a quadratic equation, we expect 4 roots. So now here you're showing that we've got 2 roots, 1 and 1. If you don't put the repeated, then it's a bit incomplete. And then for the second case, you have x plus 1 out of x is equal to negative 5 over 2. If you multiply all through by 2x, you get 2x squared plus 2 is equal to minus 5x. So you bring the if you bring the 5x to the left, you have 2x squared plus 5x plus 2 is equal to 0. And now you have another quadratic equation here to solve. You could use factorization. I prefer to use factorization whenever it's possible. This actually factorizes into 2x plus 1 times x plus 2 is equal to 0. And this gives us x is equal to negative a half and x is equal to minus 2. So yeah, you can see actually if we went with factors of 2, we had a positive 1 and then the negative 2, the positive 1 was repeated. First of all, there would be no way for us to figure out that the positive 1 is repeated. We would have the negative 2 as well. But then you'd not get, you see now you wouldn't get the negative half, you wouldn't get the other one as well. So this is the best way to do this question. If you decided to go with checking for roots first, yeah, you would get x minus 2 is a root, so x plus 2 is a factor. X minus 1 is a root, so x minus 1 is a factor. So then you would divide this polynomial 2x to the power 4 plus x cubed minus 6x squared plus x plus 2. You divide this by the product x plus 2 times x minus 1. And then this would help you reduce it to a quadratic. And then you can also solve that quadratic to get the other roots, which is x is equal to 1 and x is equal to negative a half. You could actually try this out and see that it comes out. But yeah, for equations like this where you have a little bit of symmetry, where like you have a 2, 1, negative 6, 1, 2, you see the coefficients of the terms in x are nicely written. Then yeah, the ideal substitution to use here is y is equal to x plus 1 out of x. To reduce your quadratic equation to a quadratic equation, then you solve that quadratic equation, and for the two values of y, you get two values of x for each of them. If there are no questions, then we can proceed to question 9, which will be our last question today. I'm going to ask that we hold on a bit. Let me just explain this first bit again. So the information given to us by the first sentence is explained in this equation right here. And then, yeah, when we simplify that equation using this rule right here for the reciprocals, that log of x to base c is the reciprocal of log of c to base x. So we do that for all the 4 terms in there. And then that simplifies to what we have down here at the bottom, log of b to base x out of log of c to base x being equal to log of a to base x divided by the log of b to base x. Now, that finally leads us into this right here. Again, using the change of, this is using the change of base rule. The log of b to base is equal to log of a to base b, and then we change the base here from this. In both sides, we change the base to base b, so that we have ln b out of ln c is equal to ln a out of ln z, and then we're able to prove what was required. Now, to find the common ratio, if the sum to infinity exists, then the common ratio has to be the absolute value of the common ratio has to be less than 1. That's how the sum to infinity exists. Like I said, if x is equal to 1, then we're going to have a 0 out of 0 in this case right here, because the log of 1 is 0, no matter the base. And therefore, that just can't work out. So we need x to be greater than 1. How do we need x to not be 1. How do we get the common ratio? So the common ratio actually is already given to us. The common ratio is the ratio between any two terms. So the common ratio we have there is the log of x to base b out of the log of x to base a. But we saw this actually simplifies to, if you look at the steps, this simplifies to this, this simplifies to this. Let me just write that. So this is the log of a to base x out of the log of b to base x, but this is actually the log of a to base b. Yeah. So all we need is that the log, this is the common ratio. So this is our common ratio. We just need that the log of a to base b, absolute value here, is less than 1. So we need that to be a fraction. Yeah. And that would only happen if a is less than b, I think. Absolute value. I think it's safer to use this. Absolute value of a is less than absolute value of b. B has to be positive, but yeah, they both have to be positive in this particular case. But yeah, so absolute a should be less than b. Yeah, so that would be the condition, but that's the common ratio. The common ratio is just the ratio between consecutive terms. Yeah, so a has to be less than b for this to be true. But that's the common ratio. It's really not a difficult part of this question. This is the common ratio right here, and this condition of a being less than b is imposed by the fact that the sum to infinity exists. Are there any questions on this? There are none, then I can gladly say we've come to the end of the seminar. Thank you all for attending. There was a feedback form sent in the chat. Let me just send it again so that we can all access it. Sum to infinity is if you have a geometric series that converges. So we say it converges, meaning that it approaches a particular sum but never really reaches it. That's the sum to infinity. Yeah. So I've come to the end of the seminar. Thank you all for attending. Please subscribe to the YouTube channel. The recording will be posted there. Share the links. I'm just going to share the links one more time. And yeah, thank you for attending. Have a nice weekend. Please wait for me to share the links before you leave, in case you hadn't already done the needful. But yeah, have a nice weekend. People have been asking about physics seminars. No, we only do mathematics right now. Yeah, so we also don't think we'll have more seminars this holiday because of time. But we'll continue having discussions in the WhatsApp groups. So I'm going to send the links to those so that we can continue engaging during this holiday. Yeah. Thank you. Have a nice weekend. Please wait for the links.